You ever stop and think about what's actually making your phone work or your laptop? What's the magic behind the screen? Well, today we're going to pull back the curtain on the real unsung hero of all our tech, the operating system. Welcome to The Explainer.
So, here's the plan. We're going to start with what an OS even is. Then, we'll jump in a time machine back to the age of mainframes. After that, we'll check out the big multitasking breakthrough, see how the personal computer changed everything, and wrap up with the OS that's probably in your pocket right now. All right, let's dive in.
Okay, so Section 1. Let's start with the absolute basics. What exactly is an OS? We're calling it the computer's conductor, and you'll see why in a second.
So let me ask you, what do you think is the most important piece of software on your computer? Seriously, think about it. It's not your browser, it's not your favorite game, nope, it's the operating system, that silent engine that's running everything in the background.
The OS really has two main jobs, and they're both super important. First, it's like the ultimate traffic cop for your computer. It's managing all the messy hardware stuff, the CPU, the memory, the hard drive. Second, it provides a clean, simple stage for all your other apps to run on. So an app doesn't need to know how to talk to the hard drive, it just talks to the OS, and the OS handles the rest.
Okay, now let's rewind the clock. We're going way back to the age of mainframes. And trust me, the big problem back then was just plain inefficiency.
So picture this. It's the 1940s, maybe the 50s. Computers have no operating system, none. They're these multi-million-dollar beasts locked away in special air-conditioned rooms. And using one, oh man, it was a totally manual, slow-as-molasses process. The biggest issue was just how incredibly inefficient the whole thing was. The first big idea to fix this was something called the batch system. A human operator would literally collect a stack of programs, on punch cards, mind you, and then feed this batch of jobs to the computer, one right after the other. It was a bit better, but still painfully slow. And the worst part? Once you handed over your cards, that was it. No interaction. You just had to sit and wait.
All right, that brings us to the next big breakthrough, multitasking. I mean, the problem was obvious, right? How do you make these super expensive machines useful for more than one person at a time? This was the sharing revolution.
And the solution was a total game changer, multi-programming. The operating system basically learned how to juggle. It would switch between different jobs so fast that the CPU was always busy doing something useful. And this created this incredible illusion that a bunch of programs were all running at the same time. This is what led to time sharing, a huge leap forward.
A really key system from this era was called Multics. Now, it wasn't a huge commercial hit, but wow, was it influential. Ideas we just take for granted now, like having folders inside of other folders, were really hammered out in Multics. Its core ideas directly influenced the creation of Unix. And Unix? Well, Unix is basically the granddaddy of almost every OS you use today, from macOS and iOS to Android and Linux.
So, up to this point, computers were still for a select few. Experts, big companies, universities. The next big revolution was about bringing that power to everyone. This is the personal computer revolution. The problem was, computers were powerful, but they were not at all user-friendly. The solution? A whole new way to talk to them, the graphical user interface, or GUI. I mean, this was everything. Instead of typing in all these weird, complex commands, you could just point and click. This right here is what made the personal computer possible for the rest of us.
And then, the fourth generation just exploded onto the scene. You had the dawn of the PC in the 80s with systems like MS-DOS. But then, in '84, Apple drops the Macintosh, and its GUI just blows everyone's minds. A year later, Microsoft jumps in with Windows 1.0. And while all that was happening, this guy Linus Torvalds releases the first Linux kernel in '91, a totally free, open-source alternative that would end up being a huge deal.
And that brings us right up to the modern mobile era, the OS in your pocket. Because the next big challenge was, how do you take all that power and shrink it down to fit in the palm of your hand?
I mean, think about what today's operating systems are doing. It's kind of mind-boggling. On your laptop, your phone, even your watch, they are juggling so much stuff behind the scenes. We're talking multitasking, constant networking, security, syncing with the cloud, and they have to do it all while being super careful with your battery life. It's an incredible balancing act.
So when you look at the mobile world, it really boils down to two giants, Android and iOS. And what's fascinating here is how Android got to be so huge. Remember Linux? Well, Android is based on Linux,
And because Google made it open source, any company, Samsung, you name it, could grab it, tweak it, and put it on their phones. That decision is why it just exploded across the market.
So when you see all these features, they're all there for one reason, to make sure that when you use your device, it's fast, smooth, and just works. Every single time you unlock your phone, you're standing on the shoulders of decades of operating system evolution.
So, here's the bottom line. It's actually pretty wild when you think about it. In just a few decades, we've gone from physically handing punch cards to a guy in a lab coat to carrying a legitimate supercomputer in our pocket. And the silent, invisible force behind that entire journey, the evolution of the operating system.
You know, your OS manages pretty much your entire digital life right now. So the real question is, what's it going to manage next? As our world gets more connected with AI, smart homes, and AR, you can bet the operating system will be right there in the middle of it, pulling the strings. Thanks for joining this explainer.